Okay. In this video, we will be talking about the determination of the sample size. Okay, so on the upper right, we have here the formula for the confidence interval for mu under case 1. And this portion, z alpha over 2 times sigma over square root of n is what we call as the margin of error. So keeping all other things constant, we would want this margin of error to be as small as possible, right? When the margin of error is small, then you have a more accurate confidence interval. So assuming that the 95% confidence remains the same, if your confidence interval is, for example, 2.6 to 2.2, you would prefer that kind of interval as opposed to something like 2.5 to 2.7, right? You would want a margin of error that is as small as possible. So keeping everything else constant, one way we can make the margin of error smaller is by increasing the sample size. So as you can see here, the small letter m, which is our sample size, is in the denominator. So by making this bigger, we are able to make the margin of error smaller. So the question for us now is how big a sample is needed in order to minimize the margin of error to a required level. So if the sample mean is used as an estimate of mu, we can be 1 minus alpha 100% confident that the error will not exceed a value e when the sample size is at least this value. So going back to the previous example, assuming we have a 95% confidence level, how large a sample is needed if we do not wish our error to exceed 0.05? So again, if we assume 95% confidence, then your alpha would be 0.05 and z of 0.025 would be 1.96. Now, plugging all of this into our formula, so you will have 1.96 squared times sigma squared. So again, in the previous example, sigma is not known, but we used the sample standard deviation, which was 0.3. And we divide this by the required margin of error. So the question is, you do not wish the error to exceed 0.05. So you divide that by 0.05 squared. Okay. And solving for this sample size, you will get an answer of, so you can try to solve using your calculators. And you should arrive at 138.29. Now, what this means is that if you want the error not to exceed 0.05, you will need at least 138.2976 as part of your sample. Okay. Now, our samples here, we assume them to be discrete always. Okay, so like in the previous example, our samples referred to college students. So what we will do is we will always round this up to the nearest integer so that the required sample size is 139. Okay, so again, for this particular problem, we always round up.